So 7.6 is all about dilations. Have you guys heard the word dilation before? Or dilate? Like at the eye doctor. What does it mean if they say we're going to dilate? What do they dilate at the eye doctor, you remember?
Yeah, right.
Oh, that's another one, yeah. That's a little more personal. Let's just stick with the eyes, okay. When they dilate your pupils. So they put little drops in your eyes. What happens to your pupils, do you know? They get big, okay? Or if you shine a flashlight in someone's eye, their pupil gets smaller. That's a form of dilation as well. So dilation just means getting bigger or smaller. So same as at the eye doctor or at other types of doctors. When something is getting bigger or smaller, it's called a dilation. Do you guys have any questions related to the math or the eye doctor? We'll leave the other one out of it. So there's two forms of dilations. So if the definition for dilation is a little bit intimidating, I would focus on the bottom two. Dilation is just a reduction or an enlargement. When we talk about a reduction, you've probably heard that word before. Anytime you reduce something, it gets smaller. So a reduction, the image, that's the new one. So the image is smaller than your original. If you're enlarging something, the image or the new one is larger than the original. So again, the definition for dilation, you do need it in your notes. It's something you should be familiar with. I do think it's a little wordy for what we're doing. I would focus on these bottom two. Just remember that a dilation is either a reduction or an enlargement of the original to the image. The image is the new one. So before every example, I want to show you some practice problems. So this is something that's super new. I know you guys haven't really seen anything like this before. So when it says practice, you don't need to write it in your notes. So you can just put your pencils down. You can just watch, soak it all in, and then on the next slide, you'll get to try them. So we are supposed to decide if this dilation is a reduction or an enlargement. The main thing to remember is that the little prime, it looks like an apostrophe after the P, that shows us which one is the new one, okay? So this is the image or the new one. This one's the original. So did the original get bigger or smaller?
It's smaller, bigger.
Which one is it? Yeah, this is the original, this is the new one. So the original had to get bigger to make the new one. Everyone see that?
Yeah.
That means that you are working with an enlargement. Alright, take a look over here. Here we have x, y, z. Here we have x prime, y prime, z prime. Which one's the new one?
Reduction.
Yeah, the new one is the littler one, right? The one with all the primes after the letters?
Yeah.
So if you look at the original, did the original have to get bigger or smaller to make the new one? Smaller, so this is a reduction. So these are kind of tricky. This is the center, and then you'll have the two figures, and then there's sort of just lines that connect them all, kind of show the pathway. So you should focus on the triangles, or sometimes they're quadrilaterals, or whatever figure we're talking about in that example. Questions on these two? All right, here are the ones that I want you to get in your notes. So here's example 1. We have part A and part B. I'll give you a minute to draw these, but we're doing the same thing. We're just saying if we're working with a reduction or an enlargement. All right, let's take a look at these. So in Part A. Which one's the original? Which one's the new one?
Original is the big one, and the new one is the small one.
How can you tell the difference?
One big one. Yeah.
The new one has what?
Oh, the new one got
The new one has these little symbols, okay? The little like apostrophes afterwards, all right? Those, when you say those out loud, it's prime. So the one with the primes, K prime, J prime, L prime, those are the new ones. This one's the original. So what did the original have to do to make the new one? Bigger or smaller? Bigger, which means it's in enlargement. Good. All right, and then B, which one's the original, which one's the new one?
The original is small.
The
original is the big one.
The original is the big one. The new one is the one with all the primes. So what did the original have to do to make the new? Yeah, it got smaller, so this is a reduction. What are your questions? All right, before you put your pencils down, I do want you to add one thing in your notes from this. It's down here on the bottom. Hopefully you can see it. I want you to write yourself a little note about scale factor. Scale factor, can you guys see this blue box down here?
Yep.
Scale factor is always the distance from C to P prime over C to P. So it's the distance from C to the new one over the distance of C to the original. If you flip-flop them, you will get this wrong. The prime goes on top. And then I'm actually going to change B just a little bit. So these are our practice problems, so you don't need to write them in your notes. You can just sit back and watch, but I do want you to write that the scale factor equals C prime over CP. CP prime over CP. Okay, so look at letter A. So I want C to P prime first. What's the distance from C to P prime? 2. So 2 goes on top. Then I want on the bottom the distance from C to P. What's the distance from C to P?
3.
3. So this is 2 over 3 is your scale factor. Questions on that one?
No.
All right, on the next one, same thing. I want C to P prime. Well, how can I find from C to P prime? C to P prime.
That's 3. No, that's 6.
It's 6. How would you get 6 from this?
Plus 3.
Yeah. So sometimes they give it to you like this, where they sort of do the adding for you. They give you the whole length. Sometimes they give you the 2 smaller lengths, and to find the whole thing, you have to add them together. So just be aware of that. But yes, it is 6. We want the distance from C to P prime on top. So 3 plus 3 is 6. What's the distance from C to P? 3. Now, if you can reduce it, you need to reduce it. So this is going to be 2 over 1. You should notice as you're going through these, do you see how this one was a reduction? The original got smaller. When it's a reduction, this number should be smaller than 1. Okay, so it's a fraction, not an improper fraction. Okay. Whenever here, like here we went from a littler figure to a larger figure, it's an enlargement. When it's enlargement, you should have an improper fraction. The fraction should equal more than 1. So you'll notice that as you go through them. When the scale factor is smaller than 1, it's a reduction. When it's greater than 1, it's an enlargement. Questions on practice 2. Again, this is not required to be in your notes, but the next slide will. Are we good? All right, these are the 2 I want you to get in your notes. All right, so anytime we're looking at scale factor, you have to put CP prime on top of CP. So I'm just going to write that up here. So what's CP prime in part A? CP prime. Anyone? We want CP prime on top. So what's C to P prime? What's the distance? 21. What's C to P? 14. Now 7 goes into both of those. 7 goes into 21 3 times. It goes into 14 twice. So it's 3/2. And then part B, again, we want C to P prime first. How long is it from C to P prime? Good. And then C to P? 40. Good. So some students in my last class were trying to decide, like, does the bigger number always go first? Does the smaller number always go first? It depends on the problem. Don't think about it that way. Think about it C to P prime over C to P. All right, and then anytime you can reduce. Those are both even numbers. 2 goes into 22 11 times, and it goes into 40 20 times. I cannot stress enough how important this order is. C to P prime over C to P. Questions?